Hello everybody and welcome to my shop. In today's video we're going to go ahead and wire up a TB6600 stepper motor driver. It's going to be wired to this Arduino Uno and it's going to power the Nema 17 stepper motor with the blue gears over here. Also wired into the same Arduino is the A4988 stepper motor driver that we used in the previous video, and it will be powering the Nema 17 stepper motor with the red gears. So if you have not seen the video that I just did recently, please go watch that now. I'll put a link down below. I'll put one up on top. But I go further into detail on the wiring and how to set the VREF or the current limiter in that video. I'm not going to go over that in this one because we just did it in the last one. So this video is more focused on the TB6600 driver, and we're going to be comparing the two together. So comparing the pros and the cons and the specs. By the end of the video, we're going to find out which one of these I will be using in my next project that I've already started actually, and it's going to be an HO scale model railroad turntable. So basically going to be building the turntable and all of the controls to go with it. With that, let's get started. Okay, let's go ahead and go over the wiring for the TB6600 driver. So if we look at the top panel of this, we can see the pinout for it. This can basically be broken down into like 3 different blocks of screw terminals. The first one having 6 wires, and that's going to be for our logic going to the Arduino. The next set is going to be our 4 leads, and those are going to the motor. Then we've got 2 more on another terminal. That is our power, our 24 volts for the motor, our ground and our VCC. Now if we look at our logic, we have a negative and a positive for the enable. We have a negative and a positive for the direction, and the same for negative and positive for a pulse or step. What we're going to do is bring the ground from the Arduino to our power rail, and we're going to bring that over to this terminal strip. Then we're then going to jumper all of our negatives together for the enable, the direction, and the pulse. Then all we need is our 3 positives coming back to the Arduino. Our enable will be going to the digital pin 8, our pulse or step will go to digital pin 9, and our direction will go to digital pin 10. For our motor leads, again, go ahead and check out that other video. I go further into depth on how to tell which motor leads are for what coil. But to summarize it, basically each coil, the 2 wires coming from that coil should have continuity. So if we check a digital multimeter, we turn it to continuity. In this case, I already know my yellow and my purple wire, they should have continuity. They're going to the same coil. Sure enough, it beeps. Should not beep with the other ones. And then for our power rail, I don't have a second 24 volt power supply, so we've got the wires going to our lower power rail, and both of these Nema 17 stepper motors will be sharing the 24 volt. So from here, all we need to do is go ahead and plug these in. And we should be all set and ready to go write some code. Alright, let's go ahead and look at the code here. So we start out with our title block, same as usual. I'm just going to go ahead and shrink this. I do have a little cheat sheet set up in here, also commented out. This is just helping me know exactly how many steps it's going to take to make a full rotation at this micro step versus how many it's going to take a 180 degree turn or a half rotation. I'm also going to be putting in here how many steps it's going to take to get from one track to another. That way later on down the road when I'm finalizing this for my project, if I need to move 5 tracks over, I just take this number and multiply it by 5. So I'm just going to go ahead and shrink this for now, get it out of our way. Anybody that's watched my previous videos will notice that I normally use constant variables to call out the pins on the Arduinos that we're going to be using. However, my understanding, and if I'm wrong with this, feel free, please actually leave a comment down below and let me know. But my understanding is when we're using a constant variable, it is actually setting aside a piece of memory to store that variable and the value of it. Whereas if we use the define, it's basically going to take everywhere, like in this case, anywhere down in the program when we go to compile it and save it to the Arduino or upload it to the Arduino, it's going to find the A4988 underscore MS1, and each time it sees that, it's just going to replace it with 2. It's not actually storing a separate place in memory. So I think this is actually a little bit more efficient. So I probably should get used to using define in the future, but like I said, let me know if I'm wrong on that. Okay, let's go ahead and get into the setup. So the setup, basically we're calling out all of our pin modes. Basically everything is going to be outputs because we are outputting from the Arduino to our driver boards. Then we're going to do some digital writes. Our MS1, MS2, and MS3 of the A4988 need to go to high to set the microstep at 1/16. I've already set the jumper on the TB6600 to be 1/16 as well. That way we're comparing the two identically. Then we're going to turn around and have the directions go high for both the 4988 and the TB6600. That way they're both going clockwise. Then we're going to pause for about 10 seconds just so that we can get things going. All right, next we have our loop. I'm going to go ahead and close this. We really need to go through our function take steps first. We're receiving a couple parameters, direction, steps, and speed. And then if direction is 1, we're going to digital write to the A4988. Our direction pin will go high. Same thing with the TB6600. Direction will go high. And then if we send it as 0, both of those direction pins will go low, turning counterclockwise instead of clockwise. Next, we've got our for loop. In the for loop, we send it the steps variable, however many steps we want to take. Each time, it's going to turn the step pin high, wait a period of time, our speed, and then turn it low. And that is one step. Remember that the speed is actually not, the higher the speed is the faster you go. This is actually reversed because we are waiting so many microsteps. The lower our speed variable is, the faster we're going to go. So with that in mind, when we go back and look at the loop, first thing we're going to do is take steps. So we're going to be sending it a 1 for direction. We're going to go clockwise. We're 3,200 steps, and we're going to go a speed of 1,000. Then we're going to wait 3,000, 3 seconds, and we're going to turn around and go back at the same speed. Wait 3 seconds. Then this section is actually going to go a half a turn, but we're going to do it in a series of different speeds. We're going to start out slow, go a little bit faster, faster, and then the bulk of how far we need to go, how many steps we need to take, we're going to go even faster, and then it'll start slowing down progressively until we get to our location again. So it happens so fast in the video just because I've got these speeds cranked up pretty high. But when I go to slow them down to actually move from one track to another, you'll see a big difference. So when we get done with that, we're going to wait 3 seconds. We're just going to go all the way back to our starting point. And this will keep looping. So next we need to go ahead and start comparing, and we'll see this code in action while we're doing that. Alright, we're back in the shop, and let's go ahead and compare these two stepper motor drivers. So we've got the TB6600 wired up to the blue geared servo motor, and we've got the A4988 wired up to the red geared motor. First thing to talk about is the actual size. Obviously the TB6600 is much bigger, so depending on your situation, what you're using it for, that could play a factor. Next off, we've got the cost. The smaller one, the A4988, you can get about 5 of them for about $10 on Amazon when I made this video. The TB6600, you're looking at about $10 a piece. Still not that drastic, and we'll talk more about that cost here in a little bit because there are some differences there too. The maximum amps, and I believe this is per coil, so the TB6600 we can do up to 4 amps per coil, whereas the A4988 we can only do 2 amps per coil. So depending on the size of the motor, that might play a big factor. And even more so, how we go ahead and set that. So on the red side here, we have to set the VREF. And if you watch my previous video, you'll figure out how to do that. We go over that. It's pretty easy, it's not that bad, but it's an extra step that you have to do. With the TB6600, that's already done. It's internal. You just set the dip switch according to the chart on the faceplate of the driver itself. And once that's set, it's done. Another thing to talk about is with the A4988, we have to use a capacitor to smooth out the motor's voltage coming in. That's also internal with the TB6600. There's a capacitor and everything's set up inside there. You don't have to do anything. Speaking of motor supply voltage, so with the A4988 we're looking at 8 volts to 35 volts, and with the TB6600 we can go between 9 volts and 42 volts. So again, it kind of depends on what size motor you're going to be using. The logic supply, or the supply voltage for the logic, that actually is quite a bit different. So on the 4988, the A4988, we're looking at 3 volts to 5 volts, which is perfect for an Arduino. On the other one, we can go all the way from 3 volts to 24 volts. So my original thinking was this is great because I can use the Arduino for most of the step and direction, but then for that enable, most of the projects that I would use on an HO scale model railroad layout, we're using 14 to 15 volts. So what if we just rig up like an e-stop switch and run that 15 volts through that and back to our enable terminal on the T6600. That would work great with one exception. Once you kill the power, the stepper motor doesn't know where it's at. When you go to start it up, it could be starting anywhere it was left off. So it wouldn't know how many steps to go to the next rail or to the next track. So we'll learn about a way to get around that in a future video. So the next thing to talk about is the step modes and the micro step selection. So with the A4988, we can go up to 1/16 microsteps. With the TB6600, we can go up to 1/32 microsteps. So we can go even more accurate, smoother with the TB6600. That one can also be set with the jumpers to select what microstep you want to use, whereas the A4988, we have to hardwire that, or we can wire it in like we did here into the Arduino, and then we choose that in the code. The heatsink. So if we look at the A4988, we've got that tiny little silver heatsink. So what kind of heat are we looking at? Let's find out. So right now, with this been running for a while, we're looking at 136 degrees. Now the whole back of the TB6600 is a heatsink. We're running 83.4 degrees. So there's a pretty big difference. Again, depends on how much you're using your motors, if they're going to be running constant or if they're going to be turning on and off periodically. Depends on what you're using it for. So last but not least, we need to talk about the installation or the mounting of these drives. So the TB6600, that one's pretty simple. It's got screw slots in the bottom, or the feet. So you can just run some screws through that and mount it in whatever you want to. And the screw terminals are also make all the wires very convenient. You just plug your wires into the screw terminal, and then when you're ready, plug them into the drive, you're good to go. The A4988, however, you're not really going to want to mount the breadboard into whatever your project is. So I did find some shields, or some breakout boards, however you want to call that. I think technically it'd be a shield. I did find some other ones online, like these here, and they come with the capacitor already installed and the dip switch, so that's great, but it does add a little bit on the cost. So what I found for these two models was a range between like $4 and $9, depending on how many you're going to buy at once and who you're buying them from. So that does add to the cost. So that $2 initially that we thought, that's a little different. So for me and the project I've got coming up, I'm going to stick with the TB6600. It kind of seems like a no-brainer to me, but let me know what you think. Or if you have some other alternatives for mounting, please leave a comment down below. I'm all ears. I'd love to see what you got, or some other ideas. So that about sums it up for this video. Thanks everybody for watching. If you liked what you see, if you learned anything from it, enjoyed the video, please hit that like and subscribe, and hope to talk to you guys soon. Y'all have a great day.